Bismillahirrahmanirrahim. Welcome to IIUI, Adiala Road Campus. Subject Science for Grade 7. Students, our today's topic is magnetic effect of electric current. The term magnetic effects of current means that a current flowing in a wire produces a magnetic field round it. The magnetic effect of current was discovered by Hans Christian Ørsted. He found that a wire carrying a current was able to deflect a magnetic needle. He showed that electricity and magnetism are not two separate phenomena. They are related to each other and are together referred to as electromagnetism. We have studied the two types of magnets, permanent magnet and temporary magnet. Students, do you remember that? This is how we define them in simple words. Please take a moment and go through these definitions. We will talk about the temporary magnet. Temporary magnets retain their magnetism only for a short time or until kept under an external magnetic field. When removed from the external magnetic field, they lose their magnetism. Students, we have to see the simple processes to make temporary magnet. We use objects made up of ferromagnetic material such as iron nail and iron bar. Now, the question here is, what we know about magnets? Yes, we know that magnets attract magnetic objects like iron and attract or repel other magnets. Do you know what this property is called? Yes, this property of magnet of attract or repel is called magnetism. Students, look at the examples we saw. What is happening here is that two objects are acquiring magnetism through their processes. So these objects going magnetic because they acquired magnetism. This process through which any non-magnetic object acquires the property of magnetism is called magnetization. Yes, magnetization. This can also be called the process to magnetize any non-magnetic objects. So in these processes, we are magnetizing the ferromagnetic objects. So we magnetize these objects by understanding that electric current generates magnetic field. Students, the magnetic effect of current was that a wire carrying a current was able to deflect a magnetic needle. When current passes through this wire and we keep this compass near that wire, the needle will deflect. This will not work if the current in the wire is feeble. However, in that case, if we remove the part of insulated coating and keep the compass near the region, you will see that deflection. Now we know the fact that if we keep the compass at rest away from any other magnet, then it will allow us in the direction of the earth magnetic field. That is, red part is pointed to the north direction and the other part pointed to the south direction. Students, what will happen if we bring any magnet near this compass? Well, if we bring the north pole of the bar magnet near the red needle, the needle will show deflection. The needle now align itself in the magnetic field of this bar magnet. Students, with this knowledge in the mind, let's go back to the copper wire. Here, the electric current in the wire produces electric field around the wire. Other words, a wire becomes a temporary magnet. This is the reason that the compass needle deflects when brought near the wire.